Before today, some of you may never have seen an image like this before, nor ever heard the term sponge reef. And that's not surprising, as this is an ecosystem that only exists in the deep waters off the coast of BC and Alaska and nowhere else on the planet. Now, for those of you who are unfamiliar, you can think of this as the shallow water coral reefs you already know, but instead of corals, these reefs are built up by the skeletons of animals called glass sponges. Now, due to their endemic nature, the Department of Fisheries and Oceans has opted to protect these sponges with Canada's newest marine protective area. And they have asked our lab if the boundaries that they have set up are set at an adequate distance away from the reefs in order to provide them proper protection. Now, that is an interesting question to answer, because not only are these reefs susceptible to physical damages from things such as trawl fishing, but the sponges can be impacted by the large sediment plumes that trawls generate. And that is because all sponges are designed to effectively and efficiently pump water continuously throughout their bodies. This is how they feed and how they respire. And suspended sediments can get inside their system and either clog or damage the biological mechanism that the sponge is using to pump. However, in the lab, it has been found that these reef-building glass sponges have developed an amazing behavior in order to reduce the impact that sediments can have on them. This is something that we call the arrest-response behavior. And this allows the sponge to temporarily pause or arrest its pumping activities. And this is a protective behavior in that it prevents the sponge from getting clogged, but it does have its trade-offs in that while the sponge is arrested, it cannot feed and it can't breathe. So in 2015, we set out to test for this behavior in the field. We sent instruments down to the seafloor to one of these reefs to determine what the sediment concentrations were and what the pumping activity of the sponge was. And after analyzing that data, I have found that for the first time ever, we had recorded glass sponges arresting in the field. And not only that, but the arrests we were seeing were highly correlated with increases in suspended sediment at the time. And actually, later this year, we're heading back out to the reefs in order to determine the effect that this arrest behavior has on the sponge's health. Once we have compiled all this information, we'll be able to return to the Department of Fisheries and Oceans and tell them at what concentration of suspended sediment these arrests are happening and what impact this arrest behavior has on the health of Canada's sponge reefs. We'll also be able to make suggestions on how to improve the current protection plan, such as increasing those boundaries around the reefs. With our results, we hope to be able to arrest the trawling activities near the world's only sponge reefs so that they remain alive for a long enough time so more than just historians and paleontologists get a chance to learn about them. Thank you.